This video will serve as an introduction to parallel circuits. You can see on slide 52 with me, parallel circuits are very different from series circuits in the sense that they are not bound, or rather the electrons are not bound by one pathway. They have multiple pathways to go around the circuit. Now, we're going to only deal with simple parallel circuits. So every resistor or light bulb we have in the circuit makes its own parallel branch. But just look at the picture with me here before I show you anything new. Because we have multiple pathways around the circuit, this time when we are looking at the current, we would measure a different current through all three of these resistors. I mean, they're color coded to kind of give you an idea of what the current is doing as it makes these pathways. If we were to measure the current coming right out of the battery, well, that's all the electrons in the circuit are all grouped together. But then when they hit a junction here, they split. And some of them go this way, some of them go down through this first light bulb, and then they split again. These are junctions. If you think of your Kirchhoff junction rule, then you can see that that's happening here. So when we connect our resistors like this, again, any circuit needs wire coming out of the battery on both ends. If we chopped it off just here, well, this is a simple series circuit, but because we have a second and then a third connection in this fashion, this is a parallel circuit. Each loop, again, like I said, only has the one resistor. That keeps it simple. And the electrons have more than one path to go through. So I want you to consider something. Imagine the flow of current, flow of electrons, the current around a circuit. Consider that like people walking through a room. If you open up just one doorway in a wall for people to walk through, and say there's 50 people in the room, there's going to be a good amount of resistance for them exiting that room if it's one door. If you open up 5 doors in that room, well, now those 50 people can spread around and use all 5 doors. There's less resistance to flowing through that room. That's kind of the idea I want you to keep in mind when considering current through a parallel circuit. You've given the electrons 3 options to go around the circuit. They're always going to make that circuit. They're not going to go one way and swing around backwards and do a couple of loops before going back to the battery. Electrons will always make just one trip around the circuit in one direction. And so since we've given them multiple pathways, overall, theoretically, there's actually less resistance because there are 3 pathways here rather than just one. Keep that in mind. We're not dealing with any equations for parallel this week, but it's a little bit counterintuitive that every branch you add actually gives you less total resistance. So another factor of a parallel circuit is that if we were to pull one of these light bulbs out, well, okay, that would kill this branch, say, if we turn this light off. Well, that's okay, though, as far as these other 2 go. They still have their own connection to the battery. It's a big advantage of a parallel circuit over a series circuit, that if one part of a parallel circuit burns out, well, the others aren't going to die off because they have their own line of current feeding into them. Not so in a series circuit. As you know, you pull a component out of series, you've now made an open circuit and nothing receives any current. So just looking at some other comparisons, I have this side by side here. Obviously, the series versus parallel have a few differences. Our series only has one loop, while the parallel has multiple. The deal with the pulling of a component, killing the series, and not so in parallel. One more idea that I didn't speak about just a minute ago is that because the series circuit has all these resistors in the same line, overall giving it in general greater resistance, there's less current being pulled from the power source, the battery, to go through this line. In a parallel circuit, if we keep adding bulbs, we're going to pull more and more total current from this battery so that each one has its own line of current. You keep adding 5, 6, 7 resistors in parallel with a battery, you're going to draw more and more and more current, and that's going to overall make the parallel circuit more dangerous. Remember from electrostatics, current is the dangerous measurement in a circuit, not voltage, not resistance either. I don't think anyone's assuming that. You can touch 100,000 volts and be fine as long as there's low current. It's current that kills you. On the other hand, parallel circuits are a lot more practical because of the idea that, if one component dies, the others are fine. So it's not reliant on every single piece working to get something to power. But of course, the series circuit is safer, but less practical. That's it for this video. It's just a brief introduction to parallel circuits. There is an exit ticket to take a look at today. If you want to jump right into the parallel circuit simulation, I'm intending you to not use any equations. Just do the same thing that you did with the series circuit simulation, where you take your voltmeter and your ammeter to take your readings. I don't want you to use math to solve anything. I also don't want you to try to use the series circuit equations with parallel. They will not work. Use your measurements with the use your ammeter and voltmeter to take the measurements instead. I do have a video showing you how to set up the parallel simulation so that you can take your readings easily. I recommend you watch that before you jump into the lab. But again, you can save that for tomorrow if you'd rather, put physics to the side for today after you do the exit ticket for parallel circuits. I'll see you in the next video, and good luck. As always, you can leave me questions through email or on that question document if you need to contact me. Bye-bye.